All right, guys. So really, I should have labeled this instead of derivative of a function. I should have labeled this definition of a derivative. Definition of der. So here is the title. And it says in section 2.4 because we assume that we have textbooks, but we don't have textbooks. So I probably should have deleted this. And if you recognize this, we just finished talking about it. That is how you find your tangent slope. How we found tangent slope, and not just tangent slope. You also found instantaneous rate of change. Also, instantaneous, let's see if I can spell it correct, rate of change. Yeah, so there it is. That is the definition. Anytime you're finding a tangent slope, you're technically finding a derivative at a specific value, x value, or you're finding an instantaneous rate of change. Isn't that cool? Viekana said yes while she was yawning. Let's keep that as a note for the record. Okay, I'm sorry, miss. Don't judge me, Tiff. Tiff is judging me. I can tell because the way she's looking at me. So here it is, guys. Make sure to read all this whenever you get a chance. How do you say derivative? You say f prime. So that little prime symbol there is that's a prime. And it just stands for the derivative, f prime, f. If you say f double prime with two of them, that means second derivative. Second derivative. But we don't even know what a derivative is yet, so let's not talk about more derivatives. Then it just talks to you about what's the domain of a derivative. Well, the domain of the derivative is whatever the domain of your original function is, for the most part. So example 1, it says differentiate, that is find the derivative. Once you find the derivative, find f prime of 1, f prime of 2, f prime of 3. Okay, so what they want me to do first is find f prime x. So they want some function. So here's what I'm going to do. I'm just going to write this exactly. Write that. F prime x equals limit as h approaches 0 of f of x plus h minus f of x all over h. I come here to the side, and I'm going to say, okay, what is f of x plus h? And I'm going to write 3 parenthesis x plus h, close it, squared. I'm going to expand. F of x plus h equals 3 parenthesis x times x squared, x times h, xh, you're going to have two of them, 2xh, h times h squared. Distribute the 3. So you have 3x squared plus 6xh plus 3h squared. Okay, now we're ready. We're going to come back over here, and I'm going to say f prime of x is equal to limit as h approaches 0. And f of x plus h is what I have over here in blue. 3x squared plus 6xh plus 3h squared. And I don't know why that 6 came out like that. It looks a little funky. Minus, and I guess I don't have to put a parenthesis because it's just one little term, minus 3x squared all over h. So now I'm going to zero out what cancels out. So the 3x squares looks like they zero out. And it looks like that's it, guys. And then I'm just going to factor out an h. So I'm going to write f prime of x. And I still haven't evaluated the limit. So I'm going to write limit as h approaches 0. Factored out the h. 6x plus 3h all over h. h's cancel out. And now, as h approaches 0, I get just 6x. So my final line, I'm going to write it right here. I'm going to say that f prime of x is equal to 6x. So how do we read this? How do we say it? We say the derivative of 3x squared is 6x. Everyone say it with me? And I'll unmute your mic and say it with me. The derivative of 3x squared is
the derivative of
6x. All right, I'm going to say it again, guys, so you guys can because I didn't hear you guys say it. Like I only heard like one or two. Everyone unmute your mics and let's all say it together and see if we can sound like a symphony. The derivative of 3x squared
The derivative of 3x squared
is 6x.
is 6x.
6.
Okay, we need some practice, but we're at least saying things together. Okay, you can mute your mics again. All right, so there it is. That's it. And now it wants me to find f prime of all those three numbers. Okay, so now I'm going to come here to the side, and I'm going to go f prime of 1. I'll just plug in a 1. 6 times 1 is just 6. F prime of 2. 6 times 2 is just 12. F prime of 3. 6 times 3 is just 18. And there it is. That's it. F prime of 1, 2, and 3. Does it make sense? Yes. The number should be getting bigger because the function 3x squared is just a parabola. This is not to scale. Oh, it came out ugly. Not. Man, what's wrong with my laptop? Not to scale. So I have a function. And obviously I'm supposed to be a lot skinnier because it says 3. And what you're finding is the slope at 1 is 6, the slope at 2 is 12, and the slope at 3 is 18. So it's getting steeper and steeper the more you move to the right. And it makes sense. Don't worry, Godinez, we'll come back. Cool or not cool, guys? All right, let's go to the next page. This is an alternate definition. We use it actually pretty often. It comes out pretty often. It's the same thing. If you think about it, this is like y2 minus y1 over x2 minus x1. And I know what you're saying. You're probably thinking like Chavez. You're probably thinking one of two things. Either one, Chavez, I have no idea what you're talking about. Or two, how is that the same thing as the change in y over the change in x? Well, if I have a graph, and I'm just going to draw a generic one. I'm not saying that's the same one. If I call this point x comma f of x, and I count this point an a value, a comma f of a, you can see how it's the same thing, guys. I can call this y2, I can call f of a y1, and look, f of x minus f of a over x minus a. See? The change in x, the change in y over the change in x. You see how it's kind of the same thing? And if I want to find the tangent slope at a, look, x is approaching a, so that means this button here in green, Travis, that's not green, now it is. That button here in green is getting closer and closer to this one in red, which now I just turned green. Do you see that? So as I get closer and closer, well, yeah, you're getting closer and closer to whatever that tangent slope is right there at that point A. Cool or not cool? Okay, so I was trying to bridge that philosophy there. In case you don't understand it, what does it mean mechanically? I'm just going to use this formula. So it says, find the derivative in example 1 again, this time using the alternate definition. So when I use this definition, I'm already finding the value of the derivative immediately. So let's do f prime of 1 first. So the function was, what was the function, 3x squared? So look, I'm going to write f prime of 1 equals limit as x approaches 1, because that's a rule here. And on the top, I'm going to write 3x squared minus, okay, well, I need f of 1. F of 1 is just 3 times 1 squared, which is just 3. Minus 3 over x minus 1. Are we okay, guys? Now we just do algebra. Okay, I'm going to factor out a 3. Limit as x approaches 1. I can't do direct substitution. I get 0 over 0. Factor out a 3. I get x squared minus 1 over x minus 1. I still get 0 over 0 if I do direct substitution, but the top is a difference of what? So I'm going to write limit as x approaches 1, 3 parentheses x minus 1, open, open, close, open, sorry, x plus 1 all over x minus 1. What's going to cancel out? Boom, boom, cancels out. Now I can do direct substitution. 1 plus 1 is 2. What is 3 times 2? Well, look at that. Comma, So I don't know why my monitor is working weird today. So f prime of 1 equals 6. And we had already verified that. We got that last time, right? F of 2 works the same way. I'm not going to bother with f prime of 2. I'm going to bother with f prime of 3, just so you guys can see something different. So f prime of 3, and you guys take care of f prime of 2 later on. F prime of 3 is limit as x approaches 3 of 3x squared minus, let's see, f prime of 3. So I need f of 3. 3 squared is 9. 9 times 3 is 27 over x minus 3. And it's going to work exactly the same. So now, limit as x approaches 3, factor out of 3, x squared minus 9 over x minus 3. One more time, this is the difference of squares. Limit as x approaches 3, 3x minus 3x plus 3, all over x minus 3. What's going to cancel out, guys? The x minus 3. So finally I have, oops, let me go back to blue. Limit as x approaches 3 of 3x plus 3. And now I can just evaluate this. 3 plus 3 is 6. 6 times 3. It works. So f prime of 3 equals 18. That was that answer. This was that answer. And if we come back over here, oh, look at that. F prime of 1 was 6. F prime of 3 was 18. Did we get the same thing? Yeah, we got the same thing. You don't feel bullied, do you? Okay. Okay, so all these symbols, guys, are derivative. This is y prime. This is how you say it. This is dy dx. And look, it says dy dx, or the derivative of y with respect to x. Really, that dy dx, that really does look a lot like, look at that. It looks a lot like that, doesn't it? Yeah, that dy really means like difference in y over difference in x. So that's where the d's come from, if you're wondering, like, where are all these letter d's coming from? Df, dx really just means the difference, your derivative of your function with respect to x. And then ddx of f, that really sometimes you see it like this, where they have the function to the side and they say take the derivative of that function. So these are all just different notations. Are these the only notations? No, but they're the most common. Cool? Okay. Okay, what's up? They all mean the same thing. They all mean derivative. Ms. Vargas, she's at Trinity University. She was showing me some physics, and in a nice way. She wasn't mean at all. She was really nice. She's like, "What does this mean?" And they had something like this. And in that class, that dot meant derivative. I don't know why they chose to use the dot, but maybe that's all they could do on PowerPoint. I don't know. Every program is different. Every author is different. So it just depends. And they did have a little asterisk on the side. It said that that dot meant derivative. And I'm like, you know this. It just means derivative. And she's like, oh, yeah, it does. I did say that. Okay, here we go, guys. All we're doing now, oh, I just deleted something. I don't know what I deleted. But all we're doing now is practicing how to take derivatives, which is like instantaneous rate of change. But notice that there are no numbers. So we're just solving for f prime of x without numbers, like what the expression is. So let's see if we can do this. So find f prime of x for the following functions. I'm going to use this definition. F prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. That's the most common one. That's the more popular one. There's the other one that we just did, f of x minus f of a. In this case, we don't have a point, so it's better to use this one. Make sense, guys? So here we go. I'm going to write f prime of x is equal to the limit as h approaches 0. And I need f of x plus h, so wherever there's an x, I'm going to put x plus h. So square root of x plus h, excuse me, minus square root of x, that's your f of x. All this is over h. All right, what do I do, guys? What do I do, Tiff? Yeah, So Tiff, in case you didn't hear what she said, because she's not wearing a microphone, she said to multiply by the conjugate of the numerator. And I'm like, yes, that's exactly what you do. So I'm gonna change my colors here to indicate that this is brand new. Square root of x plus h plus the square root of x over square root of x plus h plus square root of x. This is like a magic 1, by the way. Anytime you multiply by 1, it's the same thing. So that's why it doesn't change. So in case you're wondering, the top is like the difference of squares. Chavez, what do you mean? You're always saying that. This is like a minus b. This is like a plus b. When you distribute them, you're going to have a squared minus b squared. So there's no reason to make things really hard on yourself. You can just go square root of x plus h times square root of x plus h, which is just what? X plus h. If you want to put a parentheses around that, you can, but there's no negative in the front to distribute, so I don't even bother. Here, square root of x times square root of x, there's only one term to worry about. Square root of x times square root of x is just what? X, so I just put minus x all over h times, and I'm not going to bother distributing the h, leave it alone, square root of x plus h plus square root of x. So here's what I have now. Actually this happens pretty often, so I can't just blame last year's. Last year I remember because it's fresh in my head, but it happens often. I was tutoring last year, right around, like a little earlier than this because we're going at a little slower pace. And I'm not throwing shade. I know a lot of you are like, man, Chavez likes to throw shade like in between. Like, no, I'm not. And when I was tutoring, I saw one of your classmates delete the h right here and then delete the x's. Don't do that. That's out of order. Yes, I get it. Maybe she knew that the h's were going to cancel anyways, but you cannot cancel out a term until it's by itself. So you first zero out the x's, and now you only have an h on the top and an h on the bottom. Now you can cancel out the h. Does that make sense? Now, some of you are saying, Chavez, you make a big deal about something that's not a big deal. No, here's my side note. 3 plus 4 divided by 3. You're telling me that I can just go I can't do that because I can't factor out a 3 from the 4. 4 plus 3 divided by 3 is not 4, guys. It's not. See? So if I have something like, this is a no. No. If I have something like 3 plus 9 divided by 3, well, yeah, you can factor out a 3 from both of those terms. 3, if I factor out a 3, I know you wouldn't do that, right? Because why would you? But 3, if you factor out a 3 from 3, that's 1. If you factor out a 3 from 9, that's 3. All divided by 3. Look, those 3's cancel out like that. And now you just have 1 plus 3, which is 4. Would you have done this for this? No, you would have just gone 9 plus 3 is 12. Divided by 3, you get 4. But it gets the message. So please don't do math out of order because math is the only thing that is order. And without order, there's chaos. Well, I mean, not always, but. All right, what's up? Yeah, my kids here are giving me a hard time, guys. Tell them to stop. Stop. Oh, I'm kidding, guys. All right, here we go. What do I have on the top? I have a 1 because there's just a 1 in front of that h there. That's all I got. So I didn't well, I guess, yeah, we canceled the h, but we got 1 there. So 1 over, h is approaching 0. So that means I have square root of x plus square root of x. How many square root of x's am I going to have? So 2 square root of x, there it is. Notice I didn't write the word limit. So I'm just going to say f prime of x is nothing more than 1 over 2 square root of x. That's called a derivative. Yes, yes. Beautiful math.
Do we not need to radicalize the function?
Nah, you can leave it like that.
Okay.
You can if you want to. The only time we usually radicalize the function is when we're talking about like numbers, like when we have numbers. But I would leave it alone. Sometimes they do fancy algebra and maybe you don't see this answer as multiple choice and then we'd have to do some algebra. But leave it alone. Cool? Cool. All right, let's do this one. Man, Chavez, that was a lot of algebra just for one. Like, relax. This one is going to be less, I think. Let's see. I need f of x plus h. So I'll get you guys started with that. Yes, you're right. We didn't do it last time. That's because I just had square root of x. I guess I could have just gone it. Okay, anyways, I'll just stop talking. F prime of x. I'm using my formula. Limit h approaches 0. I need f of x plus h, which is this guy. 1 over x plus h minus, I need f of x, which is just this guy. 1 over x all over h. I'm going to do common denominator. I'm going to multiply the right term here by x plus h over x plus h. I'm going to multiply the left term here by x over x. When I do that, here's what I get. Limit as h approaches 0, x over x parenthesis x plus h minus x plus h over x parenthesis x plus h. I'm showing all the steps here, all over h. We still okay, guys? All right, next step, limit h approaches 0. I'm going to go ahead and combine all this baloney together. X minus, I'm going to distribute the negative, so pretend there's a parenthesis there, and I can just go like that. X minus h over x parenthesis x plus h, close it, and then keep change flip. I can put the h right there. Now we are ready. The x's zero out, and then this h cancels out. Now we still have a negative in the front, -1. H is approaching 0. So I have -1 over, so x plus 0, that's just x. X times x is x squared. So there it is. So I'm going to say f prime of x for this function is a -1 over x squared. We okay, guys? Okay, we got another one. Another one. F prime of x. I'm writing the definition again. We're going to keep writing the definition until we know it, which according to a book that we read on memory, we're supposed to have stuff memorized after 3 attempts, but I don't really believe it. Do you believe it? Yeah, I feel like we need more than 3. Or maybe I just read it wrong and it's more than 3. I'll bring it. All right, so here we go. There's my definition. So I already have f of x, it's 5x squared. I need f of x plus h. So before I start, I'm going to do what f of x plus h is. 5 parentheses x plus h, close it, squared. All right, 5 parentheses x times x is x squared. X times h is xh, but you're going to have 2 of them. And then h times h is h squared. Distribute the 5. 5x squared plus 10xh plus 5h squared. Now I'm ready. I'm going to write f prime of x equals limit as h approaches 0. And I'm going to write that expression first. 5x squared plus 10xh plus 5h squared minus 5x squared all over h. I'm going to cancel stuff out first. So what's going to 0 out? The 5x squared is 0 out first. I can now factor out an h. So I'm going to write it over here, guys. Limit as h approaches 0. Here's the h factored out. I'm going to have 10x plus 5h all over h. The h's cancel out. And now I can go ahead and make h approach 0, and I just get 10x. So what does that mean? That means that f prime of x is equal to 10x. How do we feel, my people? Okay. Take a guess. What do you think the derivative of 7x plus 5 is going to be? No, not 7. Just 7? 7x or 7? Why just 7? That's the slope. My instantaneous rate of change is always 7 on a linear line. Always, for every tangent, on every x value for 7x plus 5. Does that make sense to you guys? All right, I'm still going to use the definition so you can see that you're just going to get 7. So I need f of x plus h. 7 parentheses x plus h plus 5. 7x plus 7h plus 5. I'm done with that. So here we go. F prime of x is equal to limit as h approaches 0. And here I need f of x plus h first. I'm going to write that one first. 7x plus 7h plus 5 minus parentheses because I have more than one term. 7x plus 5. I'm going to distribute that parentheses in a little bit. The parentheses. I'm going to distribute the negative in a little bit. So here we go. I'm going to distribute. F prime of x equals limit as h approaches 0. 7x plus 7h plus 5 minus 7x minus 5 all over h. The 7x 0 out. The 5's cancel out. And now that I only have one term there, I can just go ahead and just go do. And I just have 7. So f prime of x is always 7. So for every linear function that we have, the derivative is always going to be just a constant. Do we understand that, guys? Write that down somewhere in your notes. The derivative of a linear line is always a constant. Unless it's a vertical line, then it's going to be undefined. But the derivative of any linear line, and then in parentheses put except vertical. The derivative of any linear line, in parentheses put except vertical, and then close the parentheses, will be a constant, will always be a constant. I want to see how smart you guys are. I'll keep writing. Don't worry, finish the sentence. All right, let's see how smart you guys are. What's the derivative of a vertical line? Yeah, undefined. How'd you get that? Because the slope is undefined. Good job, guys. We're going to get 5s. We're going to get 5s on this AP exam. No, we're going to get 5s. All right, guys.